Hi everyone, we're the IDL team and we did our project on finding an ideal collator configuration. To get into the background of who IDL is, they're a commercial print shop that serves retail businesses that we as consumers see in our day-to-day lives. This includes the ordering signs at Chick-fil-A or the signs above the made-to-order kiosks at Sheetz. We're focusing on the packaging department for this project, which is responsible for the assembly, packing, and kitting of signs to send out to stores. IDL has a cyclical nature of their project work, so when they need more capacity to finish their projects, they must outsource their labor. Outsourcing labor for times in which IDL needs a larger capacity to finish projects will cause an increase in labor costs. In addition to this, they also create a dependency on temporary workers, which may end up causing an uncertainty within their supply chain. Our goals as a team is to create a plan to implement an automated collation machine that's based on the current manual process of pick and packing signs. We'd also like to provide a machine configuration recommendation.
We started with data visualization to find the signs we wanted to put on the machine. We ordered the signs by quantity, meaning we found the signs that go to every store in each store network. Once the groups were established, we used them to justify the number of bays the machine should have, along with the size of each bay. After the configuration was established, we found the current labor needed to complete the process and compared it to the labor needed to complete the process with the help of the machine. Here is an example of our data visualization. You can see how each of the signs highlighted in green show that those signs go to all 6,953 stores. The signs highlighted in red show the signs unable to go on the machine based on size requirement or the type of product. EG is a special case because there were 105 signs that go to every store. We used a clustering model to split the large group into smaller groups. The clustering model created 3 clusters. Cluster 1 had 52 signs in it, Cluster 2 had 28 signs, and Cluster 3 had 22 signs.
Using variations of the grouping methods mentioned before, we gathered our final estimate for the machine to be 25 bays. We received 2 quotes for this machine, one with bays that were 29 inches by 24 inches, and one with bays that were 19.5 inches by 27.5 inches. The latter of the two is roughly $120,000 cheaper while only losing 2% of the volume, so that is our suggested solution. The estimated labor cost savings were approximately $98,000, and IDL's budget for temporary workers is $80,000. Because of this, we feel that the machine estimate is validated. Here is a drawing of the machine. Notice that this drawing contains bays that are 29 inches by 24 inches, so the 19.5 inch by 27.5 inch machine will look the exact same with slightly smaller pockets, reducing the total length. For IDL's next steps, the most sensitive aspect to calculating labor cost savings is time, so it is recommended that they complete their labor standards for picking items as much as possible so they have an accurate estimate using time studies and most analysis to do this process. This will help determine labor cost savings even further. Moving forward, IDL can meet with the machine company, MKW, to discuss the potential purchasing of the machine in the near future. Thank you for taking time to listen to our presentation and learn about the process that we use to get this machine estimate.